So welcome everyone that's on this webinar. If you're listening from remotely or if you're listening live, it's great to be here. So I'm going to turn off my video there so that we can get started. So I spent the last, well, during COVID actually, on a dream contract. It was a dream come true for me. I had been collecting software cost estimation books. I'm a specialist in software measurement. I've been collecting these cost estimation books for the last 10 to 15 years. And when somebody would write a book, or I'd be out for dinner with somebody and they'd say, I'm writing a cost estimation book, they would, somehow we would end up talking about measurement and function points and what's the state of cost estimation. And they'd reveal they're writing a book, and it would be Keepers Jones or Dick Stutzky or even Barry Beam. And I ended up getting dedications in the fronts of the book. So I thought, jeepers, you know, I've got all these books. What am I going to do with all these? And as I'd moved different homes and over the years, I thought, what am I going to do with this? Well, as luck would have it, and maybe it's manifestation, maybe it's visualization, I don't know. But during COVID, I was volunteering and helping the International Cost Estimation and Analysis Association, which deals with the large prime contractors all over the world, the Boeings and the Northrop Grummons and the Department of Defense in the United States, you name it. If they're doing cost estimation for facilities or hardware or buildings or anything, they come to ICEAA. And we had launched a software cost estimation body of knowledge, which was being developed in bits and pieces by a team of volunteers. And the chair of ICEA came to me and said, Carol, you've been active in this and you've been participating as a volunteer. What would you think if we contracted with you to create a software cost estimation body of knowledge? We're going to base it, we will give you a curriculum that is actually being used at the Department of Defense in the United States in their BCF, their business costing and things like that. They said, we've got a software cost estimation curriculum. Would you take that and turn it into a body of knowledge? And I had no idea how actually challenging that would be. I've written books before, but I was working with a team of absolute phenomenal software cost estimators who are professional from throughout the world. And over the course of about 18 months, I worked with the team and we put together a software cost estimation body of knowledge, which is part of what's behind what I'm going to talk about today. So it was kind of like a crash course or a MBA or PhD that I got in software cost estimation. So that is now being piloted. The certification for software cost estimation body of knowledge and for a certified software cost estimator is in the works right now. So that's kind of what's behind my IT cost estimation Jeopardy, the management game that's behind the times. I've seen so many cost estimates that have thwarted good software development. So that's really what we're going to talk about today. So welcome, I'm glad you're here. Who am I? I'm a project management professional. I'm a certified function point specialist. I'm a fellow. I'm a professional engineer. As I mentioned, I'm a lead author of the International Cost Estimation Body of Knowledge, or this is wrong. I'm the lead author for ICEA's Software Cost Estimating Body of Knowledge. I'm an IFPUG past president for the International Function Point Users Group. I'm an ISO project editor for the last 20 years, founder of Quality Plus Technologies. As I mentioned, I do global consulting. I'm a published author. I recently, for the work I did with ICEA, was awarded in May 2022 the ICEA Educator of the Year, and I just became a honorary fellow in October for the International Function Point Users Group. So the only reason I mention that is not to be daunting, but to simply let you know that, yeah, I've got something to say. So whether or not you listen to me is up to you, but I have some things that I'd like to share. And hopefully, if you can take away just one little piece of knowledge from this presentation, then I've done my job. So I thought about this and I thought, you know, IT cost estimating Jeopardy. That's Jeopardy. My daughter watches Jeopardy. She watches all of the old reruns on Jeopardy. And I always found it kind of daunting, but I thought, you know what? I wonder if I could create an IT cost estimating Jeopardy. So I actually did. So let's go into this. So can't really work with teams. So let's start. So I pulled up, we've got software development costs. We've got 100 to 400, project schedule, risk and uncertainty. So let's play this. So let's start, Carol, with software development costs for 100. The answer is 250,000 US dollars. So what's the question? How much budget can I approve? Okay, great, we're on a good roll. So let's go to the next one. Let's do project schedule for 100. The answer is December 15th. So what do you think the question would be? What date did I promise this project would be delivered? Okay. Let's do risk and uncertainty for 100. Okay, what illustrates a plus or minus 400% early estimating error with early software development estimates? What do you think that would be? That's what is the cone of uncertainty? I'll take software development costs for 200. 400,000 US dollars. What do you think the question would be? What is the project team's estimate for the next project? Okay, I've got $250,000 budget. The project team came in with a good estimate of 400,000 US dollars. Let's take software development costs for 300, 225. What is the most realistic next project budget according to management? 225. Okay, they've got 250 that they can approve. So we've given them a $400,000 budget. They're going to say, you know what? The most realistic next project budget is 225. Does that ever happen? I know it does. Going to software development costs. Management knows how to estimate better than the project team. If that's the answer, what's the question? Why have the last 5 projects been at least 500% over budget? Well, because management knows how to estimate better than the project team. Does that ever happen? Is that real life? It is. Project schedule for 200. Okay, between March and September 2023. What delivery date did the project team estimate that they could deliver this yet to be named project? Let's see what happens for 300. 40 to 60% rework. What schedule factor do most estimates or many estimates ignore? Well, that we actually do 40 to 60% rework. Creating the schedule based on a precluded delivery date. Does that ever happen? Well, what is date-driven estimating? That happens to be one of the methods that management, at least, creates their budget and their schedule. Let's go to risk and uncertainty for 200. The worst of any professional industry, the worst data of any professional industry. What does author Capers Jones say about the quality of software data, software development data? It's the worst data of any professional industry. Can you believe that? Risk and uncertainty for 300, the lowest rung on the software cost estimation maturity model. What do you think the question is? How mature are the estimating methods used by most software organizations today? We're on the lowest rung. And for 400, let's see. I see as software cost estimating body of knowledge, the CBOC-S. Question is, where can I find the most comprehensive collection of software cost estimating practices? And again, that's at ICEA. So let's go back to our webinar where we were right here. So that's kind of the state of the situation that happens. I hope it's not, I hope that all of those are not happening within your organization, but I still see it. I still see, even with Agile projects, the project team will create a estimate. They will go to great lengths to produce an estimate. They will even sometimes base it on previous data, but not necessarily know to normalize or analyze the data and make sure that it's comparable, make sure that we're following good estimating principles. You come up with the best guess you possibly can, present it to management, and they say, oh, we're going to cut it in half. And we don't know the scope anyways because it's Agile, but your budget's going to be half. That's a major problem. So what is the current state of software development today? Well, the Standish Group Chaos Report, which is produced or was produced every second year. Originally, it was produced every year. They do a report on software projects throughout the world. So if we look at it, they classify projects as either being successful, challenged, or failures. While a successful project in North America, we've got the highest rate of successful projects, 31%. Wow, do you want to buy into my project if I've only got 1 in 3 chance of success? Is that a good investment? What about in Europe or Asia or the rest of the world? 1 in 4 projects is deemed successful? Ooh, that's not very good. What about challenge projects? We're hovering around 50 to 60% of projects that are challenged. And the outright failures? Oh my gosh. 1 in 5 projects is deemed an outright failure, no matter where you are in the world. Now, the good news is that Agile software development has increased this, has increased those kind of these types of situations. Well, the Standish Group Chaos Report defines project outcomes according to 3 categories. So what do they mean by success? Success means it's on time, on budget, with all the features that we had intended in the first place. What does challenged mean? Well, challenged means we actually delivered it, but we delivered it late and or over budget and or it was missing features we promised. So we had to cut down the scope. Well, what does outright failure mean? Outright failure, they've defined as being not delivered or it was canceled. It's not good reports. That's not good for us. Well, the most common reasons for software development challenges and failure, and I pulled this from a different source, but these mirror the reasons that the Chaos Report comes out with. So poor user input. Okay, yeah, we can work with that. We can fix that with training or time. Stakeholder conflicts. Well, that's going to be a problem. And that's we can fix that from a customer side. We really fix it from a supplier side. Well, we can do better project management, sure. Vague requirements, well, yeah, that's still going to be a problem, and we can fix that with having glossaries or terminology. I'm going to skip over the next one, and skills that don't match the job. Okay, that can be a problem, and we can fix that on both the customer and the supplier side by getting better training. Failing to plan, yeah, that can be a problem. So we can put in more structure. We can get in project management, get some professional project management professionals in there. Communication breakdown. Yeah, we can work on communication by getting rid of the he said, she said, and blame, and do project retrospectives and do organizational learning. So that's really good. Poor architecture. Well, yeah, that can be a problem. That can lead to project challenges and failures, and we can fix that with better planning. We might have some late failure warning signals. Well, we might not be measuring, so maybe we should start measuring. But 2 of the really big ones that are often overlooked are if we're doing a really bad job in terms of doing cost and schedule estimation in the first place, well, that's going to end up with being over budget and behind schedule. So what can we do about this? Well, the reason for that is we're overly optimistic and we've got this risk avoidance. So we need to improve our software cost estimation. And the hidden costs of going lean and mean, and we've got to do it faster, better, cheaper. We might end up with unrealistic goals, not enough resources, and hand in hand with poor cost and schedule estimation. Those are 2 of the biggest things that we overlook when we're racing to do process improvement and everything else. If we can fix our cost and schedule estimation, and we can actually do realistic estimates in the first place, we're going to be in a better position overall. Number 2, where are we at? Well, software is becoming way more dominant. And one of the things I found out, if we take an example of the Department of Defense F-35 that they're doing together with Boeing and I think it's General Dynamics or Lockheed Martin. I can't remember what the name of the company is, but the F-35 Joint Strike Fighter military aircraft in the United States, compared to the F-16, which was an older model jet, the F-35 has, are you ready for this, 177 times more computer code that's installed on that piece of equipment, on that airline or aircraft. There's 300 times the software development costs. And now 90% of that functionality of actually being able to fly those jets is delivered through software. It used to be through hardware, but now it's being delivered and controlled by software. This is a $1 trillion US investment over the last 50 years. The F-35 has been developed across 9 different countries, 23 Air Force bases. And in the UK in 2015, in a different article, they were talking about the F-35, and they said it's one of the most delayed and problematic fighter programs in history due to limitations in the flight control software. This is a big deal. It used to be that software-intensive systems, where software was a small part of the overall project. There are tunneling projects in the UK and in the Netherlands, tunneling and highway control systems where they couldn't even open because the software in the toll booths was not working properly. Even though software was a tiny piece of that overall project, software development can be a major delimiter in terms of going over budget and behind schedule. So we need to take a professional look at software cost estimation. We can't just do it on the back of an envelope anymore. And unrealistic software estimates lead to poor project outcomes. Now, I live in Florida, so we have hurricanes, and those things are absolutely unpredictable, I can tell you that. But it makes for a good metaphor. If I start out with few strong inputs, very low estimating maturity, early on in a project, as a basis for my estimate, well, what's that do? It leads me to a very weak or unreliable estimate, which leads me to unrealistic plans in terms of cost, schedule, and duration. It's going to lead me to impossible contracts, and whether it's an internal or external project, it's going to lead me to impossible targets, budgets, schedules. And what happens then? No wonder we get out of control projects. What's that end up with? Adverse project outcomes. We end up with this uncontrolled project growth because guess what? We didn't know what we were estimating in the first place. We can end up with a lot of failed or canceled projects because they're way over budget. Why are they way over budget? Because we had a really crappy estimate to begin with. We can end up in litigation. Who wins in litigation? There's no such thing in software development as a win-lose contract. There's either a win-win or a lose-lose, unless you're in litigation. But neither the supplier nor the customer wins when we go to litigation. It's only the lawyers. And we can end up with these wasted investments. That's not where we want to be. But yet we go over and we say, okay, let's push this over the fence. Let's throw this software over the fence and let's get on to the next project where again, we do the same thing. Einstein says insanity is doing the same thing over and over and expecting different results. But yet that's what we continuously do. So what is the real impact of unrealistic estimates? And unrealistic estimates, what do I mean by an unrealistic estimate? They're overly optimistic. The cost is unreasonably low, the duration is unreasonably short, and risks are ignored or avoided or overlooked. The Standish Group on US government and business said, you know what? 81 billion US dollars is attributed to canceled software projects. What could we do with 81 billion US dollars? Wow, 59 billion in budget overruns. Can you imagine building a bridge that way? It'd be kind of like saying, oh, you know what? We can build a bridge for this amount or a hospital or anything. We'd end up with bridges that look like the one depicted in the picture. And I've driven in different countries when I've been visiting or going to speak at a conference. I've seen bridges that are partially built, and I've said to the taxi driver, the Uber driver, "What is that?" And they go, "Oh, yeah, they ran out of budget. They didn't estimate properly." We don't want this with our software projects. So I thought about this and I thought, okay, what do we do? Maya Angelou said in one of her, I'm probably going to misquote her, she said, "When you know better, do better." And that kind of fits into we do as good as we can based on the knowledge we have. No one walks into work to do a really bad cost estimate. Nobody does that on purpose. We only can do what we know. So here's some lessons that I learned in the 18 months of being the software cost estimating body of knowledge author, and in working with professional cost estimators from around the world who are doing extremely professional, high caliber, very mature software cost estimation. Put together 10 lessons about software cost estimation that hopefully you can take back to your company. Even if you apply one of these lessons, then it's kind of like putting a lighthouse out in the wilderness or the ocean to guide your teams forward. So are we ready to go forward? And as Susan mentioned, I don't mind to have questions as we go. If you put those into the chat box or the Q&A, I'm happy to answer them as we go through. So let's get going. Number one, historical data-based estimating is way more reliable than theory. We don't want to drive while we're looking in the rearview mirror, but it's important to see that if we had a dumpster fire project that we're driving, that it's in the distance, that we learn from historical data. Historical data-based estimating is way more reliable than theoretical models. So if you are using an estimating model, an estimating tool, any of the software cost estimating models like Price or SearSim or SLIM or even Kokomo, you want to make sure that it is calibrated. Because as Einstein says, insanity is doing the same thing over and over. Data analysis is absolutely important. The data must be similar, relevant, and comparable. We want to make sure that if we've got project costs or project effort, that is reliable. We need to know the context. We need to know who was involved in that software cost. When we're taking a look at historical actuals, who was in the corral? Whose hours are we counting on the basis for our new estimate? What was included? What were the tasks? What kind of a project? If we're going to compare something to a historical event, meaning a project, we want to make sure that we are doing the same types of projects, using the same types of methodologies, using the same, whether it is Agile, Waterfall, Spiral. We want to make sure that we are comparing an apples to apples. And that's where data normalization is absolutely critical. We need to make sure that our historical data is captured at the same level, uses the same units of measure, the scope, who and what are included, whether overtime is included or not. Historical data is absolutely valuable because it tells a factual story that we can regress historical data into a cost estimating relationship or a scheduled estimating relationship, which are CERs and SERs. But it's absolutely critical that if we're basing our new estimate on historical data, that we've done the work. If we don't have any historical data at all that we can rely on, then we can rely on things like Kokomo, on the software estimating tools, or on things like the International Software Benchmarking Standards Group data. But historical data-based estimating is way more reliable than theoretical models or than somebody's spreadsheet that's in the back of the room. So many companies do not follow formal estimating practices. This is the software estimating maturity model that was developed out of Gallereth Consulting by Dan Gallereth, Esteban Sanchez, and a number of other people on the team. If we take a look at the software estimating maturity model at level 1, which is where if you're here, you're an absolutely good company. There's no practices, no formal practices, or it's very ad hoc. It's informal, no process. There's no estimating processes in existence at all, or estimation is performed in an inconsistent manner, or we do this thing called a swag, silly, wild, approximate guess. And poor estimates and plans are the root cause of our project failures. At level 2, now we've got some introduction to formal, and we're actually introducing a formal sizing technique, whether it is source lines of code that we have normalized, and we have a standard way of counting code, so we eliminate things like comments, things like fluff code, things like that are not actually formal software code. We normalize that. We can use function points. We can use a formal method to start collecting our actuals. It's the first steps in adopting a formal sizing technique. We have some very simple cost estimating relationships. We have our primitive use of parametric models, and processes are still informal and non-standardized. As we get into more data collection where we actually have an implemented formal estimation practice, we have a formal sizing approach, we have robust parametric estimation models, we've got formal processes that are clearly defined and communicated, we've got measurement and analysis of estimates versus actuals, we've got formal sizing, parametric estimation, and those are the key to better estimates. 4 and 5 follow along. This is similar to the capability maturity model integration that was developed by the Software Engineering Institute a number of years ago at Carnegie Mellon University. So as we move up the scale, as we start applying more formality and actually recognizing that software cost estimation is a professional endeavor, we're going to be more on time and on budget. Then that leads to, according to the chaos report, better success. But it makes sense. If you start out with an unrealistic project plan, an unrealistic schedule and budget, you're going to fail. That would be like me saying, oh, team, I'd like you to go out and build a 3-story hospital for $100,000. You'd look at me aghast and say, are you kidding me, Carol? That's impossible. You know, maybe if we've got just a mobile home or a trailer that we bring on site, we've got a mobile hospital like we had during COVID for a little while, we might be able to accomplish for 100,000, but even that's going to be tight. With software, bids come in at 100,000, 600,000, 500 million. Which one's right? We need to start applying measurement, historical data collection, getting better with our data, scrubbing it, and looking at software cost estimation as a professional endeavor. That's the lesson that I've certainly learned. So lesson number three, that the estimating scope determines the range of the software activities that are included. I've talked to people who've said, oh, this project is the same as the last project. And I've said, well, what's within the scope of the project? And they go, well, what do you mean? I go, well, what are you including within the scope of the estimate? Well, we need to take a look. What are we actually estimating? Are we estimating the system development end to end, which is sometimes called cradle to grave? Are we talking about including 5 years worth of maintenance, doing a software life cycle cost estimate? Or are we only talking about software development? Or are we talking about system development? Or are we only talking about design, code, test, and integration? We need to know what we're estimating so that we can get a better estimate. We need to know what did the historical data include so that we can tell the normalization, the analysis. And sometimes this takes a lot of effort. Software cost estimators can sometimes take 6 months to do a formal cost estimate of a federal department program, just the software piece of it. So if we're talking about design, code, test, and integration factors, that just covers the core parts of the process. So the other activities have to be estimated separately, or there's significant omissions that will occur in the estimate. So if my historical data only is my design, code, test, and integrate, in other words, maybe we were doing Agile software development based on a set of scoped out requirements, even at a high level. Our scoped out requirements were the basis for our contract. If we are now doing a new contract and it's going to include requirements, then we can't just use design, code, test, integration factors, because we need to also include the implementation of the software onto the hardware and the robust nature of doing requirements analysis in the first place. If we're doing software development costs end to end, or if our historical data is based on that, then we've got software requirements through to software quality testing. If we're doing system development end to end, then that's going to take us through these stakeholder requirements, not just the software requirements, but the hardware requirements, the facility requirements, much, much more. You need to know, what are we estimating before we start? And software end-to-end attempts to cover all software-specific activities, but there's also going to be higher level systems engineering activities that have to be estimated separately, wherever those are relevant. So the estimating scope is going to determine our range of software activities included. And if we don't have a historical data that covers that, then we're going to need to add to that with either percentages or some way so that we can get a good, robust, data-based software estimate. Number 4, there is not a one-size-fits-all estimating approach. Not at all. There's a number of different formal professional approaches to software cost estimation. I was really absolutely surprised by the existence of expert opinion as a methodology that a lot of commercial software developers use. And sometimes it's got a fancy name like wideband Delphi expert opinion based on PERT. Wow, that sounds pretty scientific. Do you know what wideband Delphi expert opinion based on PERT actually means? It means I get a group of people into a room. Well, actually, before I get the group of people into the room, I identify a group of people. I get them into a room. They're all experts on different facets of the software development, hopefully, that I'm going to be doing. I ask them on a task-by-task basis to take apart the project, go and individually come up with estimates on all these different tasks. And I want to know most likely, a minimum and a maximum of all 3 of those on every single task. Submit them to me. I'll put them together because that's that wideband Delphi. And then I'm going to take the minimum estimate plus the maximum estimate plus 4 times the most likely and divide it by 6. And that's that PERT piece of it. And then I'm going to get everybody in the room and I'm going to discuss it. We're going to throw out the highs and the lows and we're going to come to consensus. And those are the numbers that become the basis for the project estimate. In some situations, that's the only estimate that's relied upon. Why am I not going back to the data, which truly shows me what happened on the project? I don't know. We need to have at least 2 estimates. Anything that's important in life, we get a second opinion. Same thing with software cost estimation. So if we're way at the beginning of a project, we're way early in the software development, we may not have even identified who's going to be on the team. We're way, way high level where we've got a lot of uncertainty. This is kind of almost the cone of uncertainty. Higher uncertainty leads us to doing estimating by analogy, finding something in our database that is similar to the project we're going to be working on. A lot of uncertainty, but an analogous approach to software cost estimation is a bona fide approach. And again, we can cross-check that. Parametric approaches, well, we need to be a little bit further along. If we don't have any requirements at all or just a high level, we need to really rely on the analogy opinion. Engineering buildup is not used a lot in software development, but we can use that, especially if we're partway through the project. And extrapolation from actuals, we can say we're 30% done the project, well, we're going to estimate that. And these lines that are here, I don't know if you can see my cursor, but the lines will go from on the far left, which is high uncertainty, all the way over to the right. So extrapolation from actuals, we can start doing that even before we've delivered the project. When we start getting into sustainment, there's a number, sustainment meaning software maintenance, then we can start doing extrapolations from actuals. Number 5, quantifying software size is absolutely fundamental to software cost estimation, especially if you're doing custom software development. So software requirements, if you get a set of software requirements, the first thing you need to do is separate that out into the separate pieces of software that you're going to be developing. Think about this like building houses. I'm not going to estimate the construction of a bunch of houses together, especially, or a number of buildings, because those buildings, I might have a community center, I might have a bungalow, I've got an apartment building. I'm not going to group all of those requirements in together. I'm going to separate those out. So the first thing I'm going to do is separate my apartment building, my community center, and my bungalows. I'm going to separate all of those out. In software requirements, when I'm looking at a program or I'm looking at a system, I do the same thing. So I may start out with brand new software development on a piece of software that is going to be glue code between two pieces of COTS software that I'm going to separate. I may be bringing in a SAP human resources system to fit in with my Oracle accounts receivable system. So I may need to do configuration, I may need to do different things, but I need to be sizing these, each separate piece of software on its own. So once I've got those software requirements, I can split those up and say, what are my functional user requirements? What is the software actually going to be doing? It answers the questions, what does the software do? I can measure that using function points. I can measure that using, in some cases, people will estimate on the basis of source lines of code. But function points and simple function points can be the easiest way of actually being able to subdivide this. I want to also take a look at my non-functional user requirements in terms of how good does this software have to be? What are my quality requirements? What are my abilities, my portability, my maintainability? All of those types of things are not the same as my floor plan size. So if you think about functional user requirements, this is my floor plan for the software. How big is the floor plan? My non-functional user requirements are kind of like a building code. If I'm building a building in Minnesota or Alaska versus building it in Malaysia or building it in Florida, I've got different building codes. In Florida, we need hurricane hangars. In software, it's the same thing. My non-functional requirements can actually double my cost of that same piece of software. Higher quality costs more money. More maintainable software can cost more money. Encryption, higher security requirements cost more money. So I need to take a look at what are the non-functional requirements for this piece of software. And then I need to take a look at the technical requirements. And the technical requirements are often influenced by my functional and non-functional. Think about technical requirements kind of like blueprints for software. So if I'm building a building, I would have my blueprints, which tell me about my soffits and my concrete and my air conditioning and all of those requirements. In software development, our technical requirements are things like, what is my software development paradigm? Am I doing waterfall construction or am I doing Agile? Am I doing Java and .NET or am I using Oracle or am I using COBOL? What are my tools and my skills? All of those are part of my technical requirements. Now, my software cost in terms of what's it going to cost in terms of the labor to develop this piece of software, that's going to be a function of all three of these. So I can end up with these software development projects, which I need to estimate separately. And my software development estimate is going to be composed of an estimate of the size. Once I know the size of what I'm building in terms of my functional size, in terms of my non-functional requirements, whether I evaluate that on a scale or whether I evaluate that on a size using something like SNAP, Software Non-Functional Assessment Process, and my technical requirements, my size will lead me into what is the best effort estimate. From the effort estimate of how many hours it's going to take to build this, I can turn that into a cost estimate. And from my effort, I can also develop that into a schedule or duration estimate. So those are really important to have software sizing. Well, some people would say, well, Carol, we can't do a function point estimate when we've only got high-level requirements. We don't know if things are inputs or outputs or queries. You know, we just don't know the requirements, and especially in an Agile software development situation. Well, guess what? There's a new methodology that the International Function Point Users Group has recently standardized called simple function points. It was developed in Italy over the last 10 to 15 years, and it absolutely gives me a much more simplified way of being able to do software functional size. So again, if I take a look at what the software is going to do, and I break it down into what are my elementary processes and what are the files or the logical data that is being maintained or referenced, I can very quickly go through even a high-level concept of operations or a agile product backlog to come out with a simple function point count. Well, simple function point counts say, you know what, it doesn't make any difference if it's a read, a write, an update, a delete. We're going to take a look at each elementary process is going to be estimated at 4.6 simple function points. And that was done through regression and statistics on real data. So each elementary process is estimated at 4.6 function points. So a CRUD, a create, read, update, and delete of an entity is going to be 4 elementary processes. And wow, that's 18.4 simple function points. My logical files, each one, whether it is internal or external, no matter how many pieces of data, each one of the persistent logical entities is going to be estimated at being worth 7 simple function points. So these are all my persistent self-contained entities that have stored data, whether they're mine or in other applications. So again, we follow the same International Function Point User Group rules in terms of defining the application boundaries around each piece of software, but we can very quickly and easily come out with a functional size estimate so much faster with so much less training, and compare that very easily to our historical data. Number 7, this was something that I found very interesting, and you may or may not have seen this yourself. Software development is subject to diseconomies of scale. What does that mean? It means that the exponent in the COCOMO 2 or COCOMO 3 cost estimation equations is not 1.0. That means you may have heard that effort and size follow an S curve. Wow, what's that mean? Well, what that means is the larger a project you do, the more effort it's going to take. Okay, that's obvious. If I'm building something that is 5,000 function points, obviously it's going to take a lot more effort than if I'm building something that's 100 function points. But here's what becomes interesting, is that it's not a straight line. Why not? Here's the crux. Productivity, meaning the effort per size, actually it's the size per effort, it's the output over input, is not a linear equation. Because the larger the team is, the more that has to be put into project management. There's an equation of the number of communication channels. Every time you add a person into a project team, that introduces more communication channels. And every time you have more communication channels, you have much more interruptions, you have a lot more rework, you have a lot more misunderstanding, And that's the reason for the S-curve. That's a big dominant reason for the S-curve. However, what we can do, and I put these little orange markers onto the S-curve, if we are working in an area, there are areas of linearity where we do have a linear, an almost linear relationship on that S-curve, then we can use analogy as long as we're within that same range of size. And we can develop CERs, which are cost estimation relationships between size and effort that would be linear, where our exponent could be 1.0. So what this means is the larger the project, proportionally more effort we're going to have to put into it. Now, hardware, when you're taking a look at hardware estimation, we have the economies of scale. If I'm producing 100,000 widgets, the cost per widget is less if I'm doing 100,000 as opposed to doing only 1,000. Doesn't happen on software. It's sized to an exponent that is typically greater than 1. And in some aeronautics and Air Force type projects, that exponent can actually get up to, are you ready for this? 1.1 to 1.2. So that's going to really put your cost estimating estimates at risk if you're following what you would consider to be a linear model. Agile versus Waterfall. We know they're not the same. In Agile software development, our resources and our time is fixed, but our scope is variable. We don't know that up front. In a Waterfall, which is on the left-hand side, the scope is fixed and we estimate our resources and our time. So there's different types of considerations. Very, very, very few companies are actually doing true Agile software development. I don't know of any federal department within the United States or actually anywhere in the world that will hand a contractor $6, $8, $10 million and say, go and figure it out. Bring us back some software that's going to change our world. Just doesn't happen. In the federal government, in the United States, in Malaysia, in most of the countries in Europe, we are doing Agile execution of projects, where the Project Management Institute has the initiation, the planning, initiation, design, execution, closeout, delivery and closeout as different phases. In actuality, we're only really doing the execution, the design, coding, testing, and integration in an Agile form. So we usually do start out with at least a high level product backlog. You would never go into a project and say, we don't know how many pieces of software we're going to build. Here's a budget, here's a contract. It's never that informal. So even if we're doing an Agile software development, we still start out with at least some sort of high level product backlog from which we can actually come out with a high level scope estimation. And from that high level scope estimation, we can come up with a size, which can turn into an effort, a cost, and a schedule estimation. So even if we're doing Agile, we'd want to compare it to Agile actual development, actual Agile actual history, but there are some of the same cost considerations. So if somebody says, no, we're doing Agile throughout the estimating, no, we're not doing that. No. And I did a presentation for the Women in Agile for the in Florida. And we talked about that. We talked about the fact that people say, oh my gosh, estimates become targets. Well, then we better get better at doing estimating. We better, as an Agile software development team, better embrace the software cost estimators and give them all the information they need so that they can do a robust and actually realistic schedule and cost so that we can succeed. So that when cost and schedule estimates become targets, at least we've given them the ample information to come up with a realistic cost and schedule. from an estimating point of view. Number 9, you know what? There are so many hybrid software solutions between development and procurement. And you know what? We need to estimate from the investment stage of software. First thing, this is something that we put into the cost estimation body of knowledge. Do you know the software architecture? Do you have any idea what it's going to look like at all? Nope, we're too early. We have no idea. We can only do a rough order of magnitude estimate. And we've got rules and methodologies that we can use for that. Is it going to be a custom software development? Well, no, if it's not a custom software development and we've got standalone COTS packages, commercial off-the-shelf packages, well, we're going to follow something a little bit different in terms of estimating. Is it going to be procured or are we going to lease it? Is it going to be software as a service? Are we going to buy a COTS package? Are we going to have glue code? Are we doing service-oriented architecture? Are we doing an enterprise resource planning? Is it a enterprise data warehouse? What type of project are we actually going to be doing? Those determine what type of estimating process we need to do. We might have, there's 3 major options in terms of using COTS-based types of packages. We might have COTS products that we're gluing together. We might have an enterprise solution or a data warehouse, and there's different approaches to doing estimate. Again, as I mentioned earlier, it's not a one-size-fits-all. And one of the biggest mistakes that immature software cost estimating houses do, or software development firms do, is they do one estimate. We need to make sure that we're doing cross-checking. We need to make sure that we are doing more than one estimating model. Because if one estimating model estimates $1 million and another estimating model estimates $3 million, which estimate is right? Well, they're probably based on different assumptions. And we need to make sure that we are going in and reconciling those things. An estimate is only as good as what it actually means and being able to understand it. So those are kind of the top 10 learnings that I got from being the software cost estimation body of knowledge lead author. Realistic estimates really need to be based on historical data. And if we can base it on historical data, we can end up with a standard estimating process that is based on size, complexity, and capability. That will give us a good, reliable, realistic estimate that considers growth and risk and has cross-checks. That will lead us to more reliable plans, better cost, effort, and duration, a better estimate of what are we going to be working on. We can put those together and create realistic contracts, realistic internal projects with realistic cost and schedule estimates. But again, an estimate is only an estimate. It's not a target. And we need to have a range, not just a single number. What will that lead to? Better in control projects. If we start out with a realistic contract to begin with, we have a better chance of meeting our targets and meeting our goals. That will lead us to better positive project outcomes because we've anticipated and tracked the project growth. We can estimate, and Capers-Jones says for every month of software development schedule, typically we're going to incur a 1.5% growth in terms of functionality. We can factor that in. We can see that from our historical data. By doing risk management, actually identifying, mitigating, planning for the risks that normally are going to happen on our projects, we're in a much better position to manage those projects, raise the red flags early on before the project is over budget and is late. And we can end up getting more on time and on budget projects, which will lead to, obviously, higher chances of success. So the chaos reports were first produced in 1996. Wow, 1996. And when you consider all of the software process improvement initiatives, all of these agile methods, the SAFe, the disciplined agile, all of the different things we're doing, all of the communication, everything we've worked on, and yet over 20 26 years, we haven't succeeded in increasing the amount of on time and on budget. What's that tell you? That leads me to believe that because we never changed our estimating methods, we'll never increase our on time and on budget unless we mature our estimates in the first place. That can lead to much better on time and on budget delivery. So the software cost estimation body of knowledge, I'd be remiss if I didn't promote this. It actually consists of 10 separate modules, 10 completely independent but complementary lessons. So lesson 0 is the introduction to the curriculum. There's some really important stuff in there. It talks about why do we have 10 lessons? It's a very small lesson. Lesson 1 talks about the importance and motivation for the CBOX-S. Why do we even care? This is important for management, because if you're going to convince your management to invest the time and effort on maturing your estimation processes, they need to know why. If they say, well, you know what, software is software. This lesson includes some of the major failures. Why were they failures? It includes things like the Boeing 737 MAX, which was as much a failure in software as it was in hardware and equipment and components. So we look at what's the importance and motivation for the CBOX-S. Lesson 2 looks at the software development paradigms, whether we're using Waterfall, whether we're doing Agile, whether we're doing Spiral, whether we're doing some hybrid in between. And it takes a look at what are the different cost and effort considerations of each of those software development paradigms. Lesson 3 looks at the 5-step estimating process, which is based on some absolutely incredible software cost estimation guidebooks that the Department of the Navy, that the Defense Acquisition University, that commercial projects, we pulled it all together and come up with a very robust but simplified 5-step software cost estimation process that we can use on any type of software development. Lesson 4 actually gets into the equations. What do we need to do? How do we estimate custom software development? Lesson 5 goes into sustainment. How do we estimate how much it will cost to keep this piece of software up and running? And we're only looking at the software piece of that. Because obviously, if you're doing system sustainment, you're going to get into facilities, you're going to take a look at a lot of different things. In software sustainment, we're following a model that is based on what the Army is investing in, which is software sustainment as opposed to software maintenance. And if you take a look at software maintenance, Capers-Jones has identified about 100 to 150 different things that are put into software maintenance. So we define it, we make it very, very clear that what we're estimating is based on history and what the history actually contains. Did it include adaptive maintenance? Does it include small enhancements? We want to make sure we know what we're estimating in order to provide a good estimate. Lesson 6 gets into procured software solutions. If we're doing some COTS projects, if we are configuring, then we're going to look at things like RICE-FW, which is reports, interfaces, conversions. E is extensions or enhancements. F is forms, and W is workflows. Sometimes the forms get categorized in with reports. Sometimes the workflows get categorized in with extensions or enhancements. So this takes a look at if we've got an SAP piece of software that we're bringing in, how do we actually use RICE-FW objects in terms of doing a robust software cost estimate? The equations are different. Then we've got 3 lessons, which are kind of peripheral. We put them out as separate lessons because they're used in all of the other lessons. So we've got a lesson that's dedicated to software size. And in software size, we take a very close look at software costs or software lines of code, source lines of code, how to normalize that, how to make sure that we are actually using effective or equivalent source lines of code. What do we do for standards in counting lines of code? We look at function points, simple function points. We look at RICE-FW objects. We look at story points. We look at object points. We look at use case points. And we have a very robust and and might I say excellent, case study where we've actually sized things using the five different approaches that are ISO standardized to function points. So we actually take our case study, we estimate it in simple function points and IFPUG function points and high-level cosmic function points and NESMA function points and use case points and object points. And so we take a look at all those different things within this lesson on software size. We also have a lesson on productivity, and productivity is a way more complicated thing than just saying output divided by input. There's a lot of considerations, a lot of risk factors, a lot of uncertainty that's built into productivity, and we need to be sure of what we're actually estimating, especially when we're following along with that S-curve. And then lesson Z takes a look at some commercial estimating models, and that includes the COCOMO 2 models, and there's a number of different ones. There's COTS-based, there's regular COCOMO 2, there's function point based, there's the emerging COCOMO 3. We take a look at SLIM, the software lifecycle model, which is from QSM software. We take a look at SEERSIM, which is from Gallerith software, and we take a look at the Price S models, which has now become a new company, but is also a very robust estimating method. We also take a look at ICEBAGs and sources of data, the International Software Benchmarking Standards Group, and things that exist within the space of the Department of Defense in the United States. The CBOC-S builds on the established knowledge for, I see, a regular cost estimating body of knowledge things, such as parametric estimating, such as data collection normalization. We don't talk about how should you collect the data. That is really a core principle within the CBOC itself. We talk about, so any of the things that are circled in red are the basis and are standardized things that you need to know. Basic data analysis principles, how to normalize, regression analysis. We don't teach regression analysis within the CBOC for software. Cost and schedule risk analysis, probability and statistics. So this is a really great foundation for software cost estimation. So we're getting to the end, and I'm going to open it up for questions, but this is really kind of the call to action. I really think it's about time to abandon this idea of IT cost estimating Jeopardy. The idea that, oh, here's the number and I want you to build an estimate based on that. Here's the date that we need to have this project delivered. We need a piece of software in place. So let's go back in time and figure out when we need to be finished doing our requirements or our product backlog. Well, with CBOC-S, with formal cost estimation, with taking a look at the software cost estimation maturity model, there is a better way. And again, Capers-Jones said, and I absolutely have to agree with him, the software industry has the worst metrics and measurement practices of any industry in human history. He said that in 2018. He said medicine 100 years ago used to have the worst data, but software has exceeded that now. And in the medical profession, they have improved markedly their software or their data collection, their normalization, and their estimating techniques. I said in December 2021, almost a year ago, size and database software estimates are the key to better project outcomes, and in time will lead us to better metrics and better data. So your call to action is, isn't it about time that you looked at better ways? Take a look again at the 10 lessons learned that I've shared with you. And hopefully your projects can end up better on time and on budget based on better estimates to begin with. So I'd like to say thank you. Thank you for being part of this, this webinar, for listening to me. My information's on the screen here. You can find out more information about the cost estimating body of knowledge for software by going to www.icaonline.com. My information, my office phone number, My email address and my website address are here. My website's under redevelopment, so it's not there yet, but there's a lot of information, and drop me a line. Let me know what you thought of this webinar. Let me know what you think should be changed or things that you challenge, or send me a note for questions. I've written hundreds of articles, and I'm a co-author on a number of different books. That's the great thing about growing old. You've got a lot of water under my feet, and there's a lot of people I stand on the shoulders of through software cost estimation. So if you need training and function points, if you'd like consulting, anything, drop me a line. I'd love to work with you. And on that note, we're at the end of the formal program, and I'm going to turn it right back over to Susan Sewell.
If you have any questions for Carol, or you would like a copy of the presentation, please reach out to her directly. Carol, thank you so much for your time and your presentation.
As always, I appreciate being part of the webinar series. And yeah, this is one of my favorite things to do. I felt absolutely enlightened. And as I mentioned earlier in the presentation, this was the software cost estimating body of knowledge lead author was my absolute dream job. And now I'm taking that on with clients and improving their estimation processes. And it's like just so exciting. I feel like a little kid again. I'm learning so much.
Very great. Well, congratulations, and thanks for sharing your experience. And thanks, everyone. Hope you have a great day. Thanks, Carol.
Bye.